There's a question about this guy from the book, and this is problem 31.35. And the question is, you're supposed to rank the brightness of the light bulb. So the first thing is that brightness is power. And so for these light bulbs, which are really resistors, okay, the power equation is a couple of them, but the ones that are most applicable here is it's the current squared times the resistance and the voltage squared divided by the resistance. And so if you can reason through how the current and or the voltage compares for these light bulbs, they all have the same resistance. And so you can go a long ways doing that. Now the person that asked me about this asked why in the solutions manual they actually went through and solved for this. So that's the one thing, is that on a problem like this, if you're really desperate and you're having trouble thinking about it conceptually, you can always, this is just basically a group of resistors together in series and parallel, and so you can solve for it that way, make up some voltage, make up a resistance, and go from there. So you can always do that if you need to on the test, okay? But usually I think about these more conceptually, and so the first thing is that I know that the current, so there's going to be a current coming through here, the first light bulb, so I'll call that the current through P. That's going to be the biggest current of them all, because that current then splits off into 3 different directions right here. And so I know that the biggest current goes through P, and so that basically, from this equation here, I squared times R, it's the biggest current times R, which is the same for all of them. So I know that the P light bulb has to have the biggest of all the powers. And then I look at the 3 or the 4 remaining, and you can do this again in lots of different ways. But one thing that I know is, okay, so that if according to Kirchhoff's loop rule, okay, if we're hanging out here at this spot after the first light bulb P, we've got 3 different paths to take. I can go through Q, this way. I can go through R and T, or I can go through S and T. And that gets me from the point I am here, so the potential at this point, to the potential at the bottom of the battery. And so the potential drop of any of those 3 paths have to be the same. And if you go through the path through Q, that's the largest potential drop of the 4 remaining resistors, because you only go through Q to get down to the bottom, because again the wires are thought to have 0 resistance, and so no potential drop. So Q has the largest potential drop out of the rest of the 4, and so from this equation I can then say that means that Q has to be the next one down. And so now it's down to R, S, and T. And so here you can reason through this lots of different ways, but if you look here, the current in T, okay, the current in T is going to be bigger than the current in R, or it's also going to be bigger than the current in S. And of course those 2 currents are going to be equal to each other because they've got the same resistance. But so that the current in T is bigger. So since the current in T is bigger, the voltage drop is current times resistance. So the voltage drop in T is bigger than R or S. And so T will be the next guy. And then finally R and S have the same current, which means they'll have the same voltage drop and the same brightness / power. And so here's how I ended up with these guys.